Good evening and welcome to a new session. In this session, we are going to solve magic square problem. Magic square problem. In this problem, we generate a n by n matrix and n is an odd number wherein the sum of rows, sum of columns and sum of diagonals is same. Okay. For example, the 3 by 3 matrix is 6 1 5 3 2 4. Here we get 8. Here we get 9. And here we get 7. Now, row total is 15. This row total is 15. This row total is 15. This column total is 15. This column total is 15. And this column total is also 15. We take diagonals. This diagonal is 15 and this diagonal is also 15. Okay. So we need to generate a matrix like this. 4 by 4 also we have the same outputs. Okay. Now the logic. So now mathematical proof for it. It is based on a heuristic. The rule is start with middle element of 0th row. That is I equal to 0 and j equal to say 3 by 2. J equal to 1. Okay. Now put 1 in that cell. You can see that. In the middle element of first row, we put 1. Next, travel um, along the rows and along the columns using the following rules. If row number is 0, that is if I is 0, next row is the last row. 5 is greater than or equal to 0. Then equal to 1. Next row is the row above it. The row above it. Okay. That is I minus 1. Next. If column number is 0, then next column is the last column. If it is greater than or equal to 1, then next column is the column left to it. The column left to it. So this is I minus 1 and this is j minus 1. Okay. If in I minus 1, j minus 1 cell, before that, here create a n by n matrix with all zeros. Okay. Now, if in I minus 1, j minus 1 cell, there is an element other than 0, then go to go to next highest row, and column number remains unchanged. Okay. Suppose you are in row number 2, as there is no row higher than this, we go to row 0. So this is accomplished by taking modulus of I plus 1. With size of matrix. Okay. So everything is done, and let us go to Python to implement it. Let us start a new file. Say let n is the input. What is n? The size of magic square. Enter size of magic square. Okay. Next. Let magic square is square. Let us call this as magic square. The function name is magic. Input is size. Okay. Now so have numpy to print this 2D list as a matrix. Print numpy dot matrix. Now the 2D list you receive from the magic function, magic square. Okay. Let us write the function. So define function name is magic. Input is n. Now create the table, magic table with all zeros. 0 for j in range n, creating zeros in first row, and then for all rows 0 for I in range n. Okay. Now one more thing, by mistake you might enter even number, so this function is called only when n is even, n is odd. If n is even, just print that n is an even number. Okay, so n is integer and the other one is string. Else you call the function. Now so it is taken care of. So we created a 2D list. Let I equal to 0. So we start from 0th row and j equal to n by 2. Okay. Next. You put 1 in the middle cell of first row. So initialization is done. How for I, not I, because we use I for a different purpose. We keep the element right, say for item or for number in range. Only first number is kept 2 to n square. So 9 elements n square. So if you want 9th element also, then put +1. Okay. Now if I is greater than or equal to 1, then set row number. Call this as row number. Set row number to I minus 1. If there is a row above it. If there is no row above it, then set row to highest row. Okay, this is what I explained. If I is 0, next row is last 0. Otherwise, next row is row above it. Okay. Similarly, if there is a column left to this, then column is equal to j minus 1. If there is no column, then go to the last column. Okay, done. If there is an element in that row or column, there is an element in that row or column already, then don't go to that row and column. Stay in previous row and set your row number to row number below it using I plus 1 mod n logic. Okay. Else, if there is no element there, say it is greater than or equal to 1, not 0, or simply greater than 0. Else, you can put greater than 0. Else, or I can put not equal to 0 also. Else, I is next row and j is the next column. Okay. Now, in table ij location, you keep the number. The number keeps on increasing. First you keep 2, then 3, and so on. Okay. Now return this table. Let us run it. Invalid syntax. Rows are to be replicated. So 3 rows. Size is 3. Check. Middle element of first row is 1. 6, 1, 8, 15. 7, 5, 3, 15. 2, 9, 4, 15. 6, 7, 2, 15. 1, 5, 9, 15. 8, 3, 4, 15. Okay. Even columns are also 15. You can check them. 6, 5, 4, 8, 5, 2. Okay. So whatever logic I explained, I just used it. If there is a row above it, go to row above it. If there is a column left to it, go to that column. Otherwise, go to last row or last column. Okay. If there is already element, then go to row below it. Row below it. That's all. Very simple. I imported NumPy only for printing. Otherwise, you need to use 2 for loops. Okay. If you want to see entire code in one screen, let us do that. So now all the function is in one single screen. Okay. So let us try 5. You can check 15, 8, 23, 24, 48, 65. So this is 40, 44, 54, 65. Okay. You can pause the screen and you can check aram say all rows and all columns. So no mathematical proof for it. This is a heuristic solution. Only 2 rules. If there is a row above it, go to that row. If there is a column above it, go to that column. Otherwise, go to last row or last column. If there is already element in that row, then don't go to new row, new column. Stay wherever you are. Okay. Just change a row. Go to row below it. go to row below the previous row, no change in column. Okay. So if you remember this story, if you remember these three rules, we can easily do it. So let us try a bigger magic square for 10 is an even number. I should enter odd number. Okay. You can get magic square of any size. Okay, helps you to play Sudoku game also. So hope understood it and like it. Subscribe my channel and use it. Okay, thank you.